All right, factor by grouping. So just as a quick recap, everything that we've done, the factoring flowchart, all that stuff, we have GCF. So when we are doing factoring completely, you always should look for GCF first. So there's two binomials. Remember, it's either two perfect squares and a minus sign, or two perfect squares and a plus or minus sign, and sum and difference of two cubes. Again, that's your SOAP. Three terms is our trinomials, and the only thing that we did was guess and check, so you have your thing. So then we have four or more terms. When we have four or more terms, the only option we have right now is factor by grouping. If we don't have that, then anything more than four terms, anything more than three terms is very difficult for us to factor. So we have this method to help us out. So put polynomials into groups. Okay. You can read this. I hate reading. So you got words, you got it right in front of you. So let's go over the examples. Okay, so factor by grouping is basically exactly what it says. You group stuff together. So I have four terms here. You want to group them into even even numbers of groups. So here I have 2 and 2. There's 4 here, so that would be 2 and 2. I don't know if I said that right. We'll recap on that later. Okay, so then we take each one of these groups and we factor them GCF separately. So we take this like it's its own problem, and we take out the GCF, and we take this and as its own problem and take out the GCF. So this should look familiar. You probably have done this before. Okay, it should be a plus 2. It's all right, I'm getting there. Okay, and then you take these two and you factor out that GCF. One of the easiest things you can do to begin with, though, is make sure you always put whatever sign is there here. You may have to change it later, but 99% of the time, that's going to be your sign. And then take out your GCF, so 3. And then, as I didn't do it on the other one, but remember you divide by the GCF, just like you would have divided here. And you get what's left on the inside. And then when I divide here, I am left with a plus 2 again. So this should look familiar, and this is one of the reasons we did this back, when we did GCF. This is now 2 terms with a plus 2 being your GCF. So now we take the GCF out again, and we're left with a plus 2. And so those are gone. We divided those out, and we're left with an x plus 3. So that's that factored. So if these do not turn into exactly the same thing, we might need to rearrange here to try it, or else it can't be factored. Okay? So let's try again. So again, there's 4 terms. So the only thing we have to divide it in half. Each division, so this has 2, this one has to have 2. They have to have the same number of terms. So I'm going to take the GCF out of the first 2 terms, so that would be x squared. And when I divide by x squared, I'm left with x minus 3. Okay, so then the next one, you're looking there like, oh, wait a second, there is no GCF. Well, this is the one time where we're going to factor out a 1. Okay, just so we have that term we need. So we have this negative. Remember, we keep that. And so then we're going to factor out a negative 1. It's just so because we need something there in order for this to be 2 terms. So divide by negative 1, because that's what we factored out, and we get x minus 3. So these two, excuse me, are exactly the same now. Factor out the x minus 3, and we're left with the x squared minus 1. Oh, look, we can do more. So this is where the factoring gets super fun and crazy, which is super enjoyable to me. So x squared minus 1, it is dots. Remember, it's x plus 1, x minus 1. It's 2 terms, so look on your flowchart or just above on this sheet of paper, and you'll see that it's a difference of 2 perfect squares. All right, so here we have another one. Let's do the same process. So here we go. We divide it in half. We look to factor out the GCF. So I'm looking at it saying to myself, I don't have a GCF in these two. And there's a GCF in these two, but they don't look good. They don't look like I could make a 6 turn into a 4. So what we do is we rearrange. So the easiest way to start rearranging is to take this one right here, the second one, and move it to the end. So I'm taking this one out of this spot and I'm moving it to the end down here. So let's rewrite it. I write better if I don't talk at the same time. So, all right, so there you are. Now let's try it this way. I'll change my color to see what it looks like. All right. So let's look. What can I take out here? I can take out a 2x, divide this by 2x, and I'm left with 2x. Remember, the x's cancel out here, plus 3y. Well, what can I take out from these two? Well, remember this minus sign just goes right there. And then I look, okay, that's 14 and 21, so that looks like a 7. And there's no x's in both, but there is a y. Take the lower exponent, which is a 2. So 7y squared looks to be the GCF, that's a y. But since it was negative here, I have to make sure I divide by that negative. So negative 14xy squared divided by negative 7y squared is 2x. And then these two divided is a positive 3y. These are now exactly the same thing. So I'm going to take those out. This is now gone, and I'm left with 2x minus 7y squared. Now I do have to check them. I still have a squared here, so I should check to see, can I factor this more? And then I look at the 7, and the 7 is not a perfect square. Neither is the 2 or the x. So yeah, there is a perfect square in here, but they all have to be perfect squares to keep moving. So that one is done. All right, and then we move on to one that has more than 2. Okay, more than 4. So it's more than 2 groups. So we can either group it in half, just like we did, and group these two and these two. So if we try that, I could take out an x squared. Now the order is weird. Now you see this and this. I know you're saying, can I please add those together? Don't. If I'm asking you to factor, if anyone is, and they have it written like this, try it the way it is first. And then if you can't do anything, then try combining, because chances are we made it this way for factoring ease. Okay, so this winds up being x squared minus 1 minus 3x. This doesn't look good. And then here I can't take out a 3 or a 10. Or, nope, this doesn't look good. Okay, so this one, you could divide it in half, but that dividing in half didn't look good. Before I rearrange it, I'm going to try and, excuse me, factor it in half. So, not in half, but I'm factoring it in pairs of 2. So I'm going to take these two and these two. Okay, so now I have 3 groups, and let's try taking the GCF out of those. So x squared comes out of here, and I'm left with x squared minus 1. This is a negative, so that goes here. So 3x looks like what it is. So factor out a negative 3x, and I'm left with x squared. Ooh, this looks good. Those are the same. Then I factor out again. This is negative 10. And I get x squared minus 1 again. So that's what I'm looking for. These 3 being exactly the same. Now I have 3 terms where one of the factors is x squared. One of the factors, yeah, is x squared minus 1. So I factor that out, goes away, and I'm left with x squared minus 3x minus 10. Now I can factor these again. This is dots. And this is a trinomial, and it winds up being x squared. Yeah, I don't know what I'm doing. Here, hold on. I know what I'm doing. I just got on a roll there. So I'm going to go with minus 5 and a plus 2. Yep, because if these two add up to 2x, this is negative 5x. Those add up to negative 3x. We're done. So this is the answer. That's it, factored completely. All right, have a wonderful day.